Hello, this is Dr. James Camp from Lee College in Baytown, Texas, and I'm giving an example today on how we use object-oriented programming to do a simulation. Um, this is very similar to the kind of technique you would use if you were using object-oriented programming to write a video game that had independently simulated um, heroes and villains or um, characters of any sort. So we're going to start by planning our uh, simulation. What we want to do is a classic predator-prey model. We're simulating an ecosystem that has three characters. It's got predators, it's got prey animals, and it's got plants. The predators um, are going to eat one prey per simulation turn. We're going to assume a simulation turn is about a week. Okay. They're going to reproduce 4x. These are predators like dogs or cats, so they're going to have a litter of pups or kittens. After we're going to assume a year is 50 turns just to make the math easier. Okay. Um, and it dies after 10 years or 500 turns, or if number of prey is less than 5 times number of predators. So in other words, if there aren't enough prey to eat in the ecosystem, then predators start dying. Okay, prey is going to eat 10 plants per turn. Now we know that that's kind of ridiculous. Herbivores eat hundreds of plants in a week, but we want to keep the numbers down to make this a manageable simulation. If we had the prey eating 100 plants a turn, we'd have to have millions of plant objects, and that gets hard on our memory. So they're going to reproduce 1x after 50 turns. Okay. These are like horses or cows or deer. They tend to have one child at a time. Okay. And they die after 1,000 turns. 500 turns is 10 years. 100,000 turns is 20 years. There's a little bit longer lifespan for prey animals than for predators. Or if number of plants is less than 10 times the number of prey. In other words, if there aren't enough plants in the ecosystem to eat, then the prey start dying. Okay. The plants obviously do not eat, so the eat method for a plant will just be to do nothing. They reproduce if they reproduce after 50 turns. Same thing as everybody else. There's one time a year when plants flower and produce seeds and all of that. If less than, let's say, 100,000 plants in ecosystem. So there's a max limit of how many places you can plant a plant, right? So if all the spots are taken, you can't reproduce. And basically, we're going to say that plants live forever unless they, well, let's say to say they reproduce 10 times. They produce lots of seeds. And we're going to say that these plants live until they're eaten, just for the sake of an easy simulation. Okay. Now we need to make our design the object we're going to use for this. So I make a UML diagram here. I'm going to call this organism. Okay. It's going to have to store how many turns it's been alive. So I'm going to call that turns, and it's going to be an integer. Okay. And so that helps me do the die after a certain number of turns. Okay. And then in terms of functions, it's got to have eat, and that's a void function. Reproduce, that's a void function. And die, that's a void function. Now, the code then the pseudocode for the whole program is going to look like initialize. Let me turn this all up to size 14 so y'all can see it better on the screen. We're going to initialize 10 predators. Say 1,000 prey and 100,000, or yeah, 100,000 plants. So we'll actually have all the plants in the ecosystem that it can hold to start with. But they're going to get eaten. So yeah. Then we're going to for turn equals 1 to 1,000, we'll do 20 years. Well, let's yeah, let's do a 20-year simulation, or let's see, 25 times 50 is 1250. So we'll do 1250. Okay. We're going to call .eat on all organisms. If turn %50 equals 0, we'll call .reproduce on all organisms, and then we'll call .die on all organisms. And the organism has to decide whether it's going to die or not. We're not going to kill everybody after every turn. And then if turn percent 50 equals 0, we report totals. Okay, so we get a yearly report on how many plants, plants, prey, and predators are in our thing. So that's all the planning we need to do for this. Let's get coding. I'm going to create a new project. If I wanted to get really creative, I could make this graphical and show pictures of everybody doing their thing. But I'll leave that to y'all to figure out later. We're going to make a console application, call it Ecosystem Simulator. Okay, so we need to pound include IO stream and pound include IO manip to make our output attractive. Then we need and of course we're going to do our using namespace standard. Now we need class organism. The private data is int turns. Okay. And we're going to set that equal to 0 to start with. The public functions are virtual void eat virtual void reproduce and virtual void die. Okay. Actually, we're going to go with virtual bool die, and what it does is it's going to return to the main program whether that animal should be deleted or not. Okay. Then we just define each of these. Void organism : eat. Oh, and we need to be able to increase turn. So virtual. So this doesn't have to be virtual. This just has to be void turn. Okay. An organism : turn is just going to turns plus plus. Now we need to know how many turns we've been through for the die function. So we need an int get turns, and that's a const. So int organism : get turns it just returns the turns variable. Okay, then eat, reproduce, and die. Sounds like a good life, right? You eat, you reproduce, and you die. Copy that, paste it here, paste it here. Okay, and these are going to be empty functions that have to be overridden. Yeah, it doesn't like me saying virtual out here. Okay. Okay. So now what I need to do is define each of my animal types. Class predator, colon, remember to put the public word here, organism. Okay. Now it doesn't have any private data that we're overriding, but it has public. We're going to override eat, reproduce, and die. And we're going to note for the compiler that these are override functions. Okay, I've got green squigglies showing that I haven't defined those functions yet. We're going to do the same thing for prey. It's also going to override eat, reproduce, and die. And then for plant, but it doesn't want to eat, and it doesn't have any lifespan after which it dies. So we're just going to leave that leave it with reproduce. Okay, now I have to define all of these things. Okay, so I copy these, but this time it's not organism, it's predator. Okay, so predator eats one prey. So okay, what I need to do here is come up so I need to have all of my class definitions up at the top so that I can use them. Okay, I'm going to pound include vector here. And I'm going to have a vector of predator called preds, a vector of prey called praise, and a vector of plant called plants. So now, when I get to predator eat, all I have to do is say prey dot praise dot pop back, and it's just going to pop one organism off the prey list. So we've eaten one organism. Okay. Reproduce, we're going to say this is a little trickier, so I'm going to write a full function here. We're going to say predator baby equals predator, or we'll just say predator baby. We don't have to. We don't have a real constructor for it. Preds dot pushback baby. Okay. And now the predator, we said, is going to reproduce 4 times. So I do 4, I equals 0, I less than 4. And I create a new baby and push it back. And then die, what we said is the predator dies after 500 turns. So if get turns, so actually what we're going to do, we're just going to say return get turns greater than or equal to 500. Okay, so if that's a logical statement, if turns is greater than or equal to 500, we'll return true. And that means it's ready, it's time for this predator to die. Okay. Now we're going to copy this code and we'll do the same thing for prey. Okay. Prey dies after 1,000 turns, so there we go. Oh wait, I forgot. Okay. Predator also dies if... Okay, so this has to be a little more complicated. If get turns greater than 500, return true. Okay. If praise dot size is less than 5 times preds dot size, return true. And otherwise, return false. Okay. So my prey dot die, prey colon colon die, we're going to change this to 10,000 turns, and we're going to say if plants dot size is less than 10 times praise dot size. Okay. If we've overgrazed, prey start dying. Now, for prey to reproduce, prey, we said reproduces one time, so we don't need that whole for loop. We just have a prey called baby, and then praise.pushback baby. So we add one baby to the end of the list. Okay. Now the only place where this gets more complicated than the is we have to eat 10 times in a turn. So for 0 to 10, we'll pop back a plant. Okay. So you see, all of this stuff, because we're doing object-oriented programming, all this stuff is fairly easy to manage in our code. And then what did plant need to override? Reproduce. Okay. Void plant, colon, reproduce. We'll create a plant. We'll call this one seedling, since we don't really call it a baby if it's a plant. And the plant needs to reproduce 10 times. So one to 10. Okay, plants.pushback seedling. Okay. There we go. So now we've got all the code we need for all of the things we want to simulate. So we're going to see out starting simulation. Okay. Now we need to add all of our things. So for 1 to, well, make a couple of constants here. Const start preds equals 10. I have to tell it what it's an int. Const int start praise equals 1000. Const int max plants equals 100,000. Okay. So I'm going to take those and put them up near the top here. And what I forgot to do is for plants, we go up to this and we say if plants dot size is less than max plants, then we push back a seedling. Okay. So for start preds, we have predator new pred, preds dot pushback new pred. So we just get our predators set up, then our praise. Okay, and then we do this to max plants, plant, new plant, plants.pushback, new plant. Okay. So this initializes our simulation. Then we also come up here and we say we wanted to do 1250 turns. So constant max turns equals 1250. And this way, if I want to do more turns, easy for me to find that one place and just change that. Okay, so 0 to max turns. Each turn, what do I need to do? Let me look back at my thing. I need to tell everybody to eat. Well, first, I need to so I'm going to do the alternate for loop here that says for I'm going to do the plants first. For plant colon plants. For all of these, I want to call turn. Okay, I want to increase its turn count by 1, and I want to call plant dot eat, which isn't going to actually do anything. I want to call plant dot reproduce, and then, well, no, this is if turn %50 equals 0, then we call plant dot reproduce, and then we say if plant dot die, which is always going to return false, then oh wait, that one's going to need I'm going to have to, yeah, okay. We got plants at I. And if plants at I dot die, then I'm going to do plants dot erase, plants dot start plus I. Begin. Yeah. So if that plant needs to die, I kill it. Okay. Okay. Now before we do all this, I need to have I need to print my output line. Okay. So cout let's do set width 10. Well, we'll set width 4 for this one. Turn. And cout set width 10. Plants set width 10. Prey predators. Oh, and that's an end line because we're at the end of our output line. Okay, now I copy this and I come up here and I make a void output line function, and it's going to do all of this, but instead of printing turns, it's going to print, oh, and it needs to have an int turn. It's going to print the turn number, then it's going to print plants.size, praise.size, and preds.size. Okay, so actually I want to print years here, so okay, so we call output line for year 0. Now I've done all my simulating for plants here. I'm going to do prey next. And the cool thing about having written this with using inheritance is that all of these functions work exactly the same in my calling. I can call these functions exactly the same, so I don't have to rewrite any code here. Okay. And then when I'm done with all of that, if turn %50 equals 0, then I want to call output line turn divided by 50. Tell it what year we're at. Okay, so we've done all this coding. Hopefully you followed along with the fact that what we did was we created a class organism that had all the basic functionality but didn't actually do anything. Okay, except that it was able to keep track of how many turns it's been alive. We have class Predator, which overrides Eat, Reproduce, and Die. Public class Prey, which overrides Eat, Reproduce, and Die. And class Plant, which only overrides Reproduce because it doesn't eat and it doesn't die. Organism, we have functions that handle the turns, and we define all the other functions as just being empty functions that need to be overridden. Predator Eat is going to pop back a prey. It's going to eat one prey. It's going to eat the youngest prey, which makes sense for a predator. They're typically going to eat the youngest prey animal they can find because those are easier to hunt and kill. When it reproduces, it's going to have a litter of 4 babies and push those back on the predator's list. And then if prey's dot size is less than 5 times predator's dot size, if we don't have enough prey to eat, then we're going to die, or if we've been alive for 10 years, we're going to die. Prey, we're going to, every time we eat, we're going to eat 10 plants. We're going to reproduce by having 1 baby at a time, and we're going to die if we've been alive for 20 years, or if prey's dot size is too small. If plants dot size is too small compared to prey's dot size, if there aren't 10 plants for every prey animal to eat. Okay, then we're going to, the plant is going to reproduce by having 10 seedlings at a time. Okay. There's a error. We're going to start the simulation by populating our animals, and then for the rest of the simulation, we just call the methods that are built into the various animals, and that's what makes this an object-oriented simulation, is that we're not actually doing any of the work here in the main program. We're just letting the plants and animals do all the work. So let's see what happens when we debug this. Okay, something went wrong here. Okay, after a little evaluating, a little debugging, I ran this program with just printing out every 1 turn, and it looks like the prey are eating the plants so quickly that they're dwindling before they have a chance to reproduce, and the predators are eating the prey so quickly that they're dwindling before they have a chance to reproduce. So what we need to do is possibly, the predator can't eat less than 1 prey per week. We can't do a less than 1 for that. The prey, we could try saying that they eat 1 plant a day, 1 unit of plants a day. Okay. So make that 7. And then what we're going to have to do is probably have the predators start with fewer. So let's say we start with 4 predators, just like 1 little pack of wolves. Okay. Start the prey the same, and then start the plants with 1,000,000 instead of 100,000. see what happens now. See if the ecosystem will make it to reproducing. Okay, so in this instance, the prey diminishes, but not that much, and the predator does make it. So let's say, so I can now go up to my max turns and go back to 1250, the original amount I wanted to simulate for, and I can come back down here and go back to printing out every, let's print out every half year. Okay. And see what we get from our ecosystem simulator. Okay. We get the prey are being eaten in half a year by 900 of them. Now we're going through the reproduce routine, which is taking some time on the simulation. Let me see if I can up the font size on this so you all can read this on your screen. Okay, so I'm thinking it's going to take a little too long to simulate 1250 turns. So let's go with and maybe the max plants at 1 million is a little too much for my computer, but we'll see. Let's go to just 250 turns. That's 5 years. And we'll print output every every 10, 5 times a year. We'll print output 5 times a year. And let me see. If I go into release mode instead of debug, that usually makes the program run faster. So let's see if all these things together. Okay. So it's taken a lot of time to do its reproduce business here. Because a lot of plants and animals are reproducing. Probably could have written that more efficiently. Let me see where I am in. We're in predator reproduce right now. Okay. And we're at I is oh, we turned off the debug information. Okay. But we're at the predators, so there should only be a little more work to do here. I'm not sure what just happened. Uh, okay. I'm going to start my max plants at 500,000 instead. I'm going to turn the debug back on just in case we want to be able to watch this. The plants are going to reproduce again. Okay. And we tried to pop something off an empty vector. Okay. Well, so this program needs debugging. You can see that the reproduce part, when we get to the reproducing, um, things get a little funky and the program slows down hugely because we're going through and reproducing each thing. But uh, for the first year, if we want to run this for 49 turns and um, print out the full uh, simulation, we can get what predator and prey look like over 1 year. Um, Plants get grazed down quite a bit. Um, the prey animals get reduced by about 20%, and that's with 4 predators. And we can. The nice thing is this is a simulation, so we can play around with what happens if um, my pack of predators starts out. What if I seed them with 6 predators instead of 4? Um, I could get now I reduce the prey population by about 30% instead of 20%. Okay, so and that's how object-oriented simulation works. Is we create objects, we give them jobs to do, such as eat and uh, reproduce, and optionally die if there's not enough food, uh, and that uh, that allows us to simulate a scientific problem in this case, or to simulate the creatures that populate a video game or any other kind of object-based simulation you might be interested in. Okay, I've run out of time for today. That's my video on object simulation, and that pretty much wraps up our class on C++ programming. We'll you now know how to do a good chunk of what's possible in C++, though of course it's a very complicated language and there's a lot more to learn. And I'll continue to post videos over the rest of my life, probably, as I try to teach more and newer skills. Okay, thanks for watching. Happy programming, and I'll see you around.